And now we're going to take a look at perhaps an aspect of 5G that's often overlooked because the RAN and standalone seem to attract more headlines. It doesn't mean it's not seriously important. I'm talking about the transport network. And I'm delighted to welcome Anuradha Udunuwara, and I can only apologise for not pronouncing that very well. And he is Senior Enterprise Solutions Architect at Sri Lanka Telecom. Over to you, and thank you very much.
So thanks for the introduction. And as Annie mentioned, I'm not going to talk about 5G in the broader sense, but rather I would select the area of 5G in the transport domain. So often we see that the transport part of 5G is not comes to the mainstream discussions, but everybody talks about 5G use cases and how 5G is going to deliver different number of capabilities. So in this discussion, we're going to look at a few things, 5G transport network and what are the expectations and what sort of design requirements goes into the network design process, and sort of challenges, especially what sort of investment approaches service providers can take, especially in constrained markets and developing economies. So if you look at the 3GPP's 5G system view, it's a very simple diagram like this. You have the UE, you have the next generation RAN, and you have the 5G core. Only three separate pieces connected over different reference points or interfaces. So what you see between the G node B and the 5G core is this reference point defined by 3GPP, which is the NG reference point. Now, this is where most of the transport involves between the G node B and the core, depending on how do you really want to construct your G node B and what level you sort of going to disaggregate the different components in your radio access network. And what sort of expectations, or rather what 5G expects from the transport network is not something greatly discussed or something that is very well defined in terms of standards as such, but we need to sort of derive it from the IMT 2020 and other ITU and different other standard developing organizations, the way they define the capabilities that 5G as a service is going to deliver. So if you look at one key capability that 5G is expected to deliver is this high data rates, gigabit transport. And then we have this requirement of the density, device density, which in network transport terms is actually, let's say, 1 gigabits per second, and so many users or devices consuming 1 gigabits per second in that particular square meter or square kilometer area. So that aggregated traffic and the data rate. And then you have the famous other capability that 5G is expected to deliver is low latency. It actually comes with ultra reliability, but the key requirement for the network point of view is the low latency, and we're talking about milliseconds and sub-millisecond latencies. So these are the sort of key inputs that one would consider when actually they try to define and design their transport network for 5G. And this is a couple of years back. It says road to 5G transport is the top priority for telecom operators. Now, for example, if you take a market like Sri Lanka, where I come from, 5G spectrum is not yet released by the regulator. So we are still waiting the regulator to release the 5G spectrum with a lot of uncertainties. But that doesn't mean that service providers like us, we need to be ready with the moment the 5G spectrum is released, that of course we have an investment towards 5G, of course, for the spectrum and also for the other rollouts. Now, a few years back, it was sort of at very high level, it was mentioned that it would cost something like 15 million US to acquire the spectrum, and another 100 million US for a period of years for the rollout investments. So although we don't build transport networks just for 5G, a transport network for a service provider or a telecom operator is going to carry not just 5G services, but other services, mix of services, residential, business, enterprise services, mobile services, wireless services, fixed services, etc. So, but the priority is because everything depends on the transport network. Even if you have the radio access network ready, radio access network also has a part of transport. But if you have the antennas and the other stuff ready, and also the core network ready, if you really don't have the interconnectivity between the RAN side and the core side for different services, then you are in trouble. So this usually identified as a infrastructure resource layer among the other layers like the business enablement layer and the application layers, etc. So you can see on a vertical view that there are a lot of things dependent upon the infrastructure resource layer. So transport used to be, I mean, mobile backhaul. That is something that we used to call it for a longer period of time from the days of 2G. It was just a backhaul, but from 4G onwards, as we move to 4G, 5G, and 6G, and other future mobile technologies, we see this introduction of the front haul, the mid haul, the back haul, and in the future you will have other segments as well, making the scope and the domain of the transport expanding towards different areas because of this sort of architecture that we have with 5G, with all the disaggregation, modularity, openness, and several other things like control, user plane, data plane separations, etc. And most of these implementations requires mobile edge computing, or the edge getting closer to the base station or the user, requiring the implementation of different miniature level DCI type of connectivity. All these mid holes in this diagram, and to a certain extent back holes, are although we call them as transport, they are essentially constitute something to what the industry refers to as DCI, and these DCIs are not the large scale data centers, but miniature versions, mostly hosting mobile edge computing or multi-service edge computing. And if you look at the sort of Capex structure the telecom company would have with regard to, not necessarily with regard to wireless operations, but other operations as well. This surely shows, or rather clearly shows, that transport, including RAN, radio access network, has a transport part and also a RAT part, or the radio access technology part. But it's close to 50% of the total Capex model that we have, transport and access. So if you remove the fiber or the copper or the radio access part, if you leave it alone, still it's a considerable amount, although it is shown as 10% for transport. Access also includes, because of front haul and back haul, for transport. So with that background, let us now consider some of the areas that as service providers we would consider in developing networks or designing networks for 5G, predominantly to support 5G requirements and also to support other requirements. Because as I said, we are not going to build multiple transport networks for multiple services. So we have a common transport network. Luckily, we have sort of agreed or rather common consensus that everything is going to be on IP, every service, 4G, 5G, and other fixed services as well, everything is based on IP. So we have a common protocol to transport, but there are different considerations that one would take in designing these networks. So that includes, for example, how to incorporate the optical domain and the IP domain. Should I have an overlay IP network on top of optical, or sort of try to integrate, consolidate IP and optical together? Because these days we see a lot of pluggable optics available in the market. Or should we have a mix, for example, core and aggregation network? Because of large capacities, you can have an overlay network architecture, but as you move to the access level or second level aggregation, you could even try IP over DWDM. And then you have different shifts of protocols as we move forward. We see we are moving from a traditional IGP type of forwarding to predominantly using ISIS and IGP, and then moving to SRMPLS and SRv6. And traffic engineering move to SRTE, and service protocols, if you want to compare them, like traditional MEF type of services on Ethernet services and IP services. IETF IP services are moving to a common umbrella of Ethernet VPN, and plus using BGP as multi-protocol BGP as the universal control protocol for all the services. And then configuration also changes from the traditional ways of controlling, or rather configuring, from the traditional SNMP to NetConf and YANG. More of a template type of defining the network. Once it is abstracted at the program level, you sort of define the requirements and use a template to configure the network. Same for management protocols as well. And if you look at the optical transport network more closely, again, you can see the technologies like optical transport network, or the OTN, together with DWDM ROADMs, is also having multiple options. Like the debate is like, should we have OTN, or should we just use DWDM ROADMs, and on top of that implement the IP network? But if you go with OTN, again, you have two options to use OTN framing, which enables you to have sort of regeneration type of things, and also it supports multiple payloads. But supporting multiple payloads really doesn't mean anything in these networks, because we are predominantly talking about Ethernet payload at that level. And OTN switching, if you want to have, then you're talking about things like sub-lambda grooming and layer 1 ASON type of protection. But as you go to higher speeds on interfaces like 100 gig, 400 gig and above, do you really need sub-lambda grooming is again a question. And if you really look at the pluggable optics these days, you're talking about coherent and non-coherent optics. Most of the optics today used in networks above 100G are actually coherent, and then below 100G use the traditional direct detect type of interfaces. And of course, there are certain restrictions in vendor implementations mixing these two together, like coherent and non-coherent in the same here. And then some vendors support pluggable optics with a lot of built-in optical capabilities like transponding functions built into the optic SFP. And we often see most of the SFPs, the future SFPs are CR and CR plus coherent optics. Now, why 100G coherent is important? This survey report from Heavy Reading shows that when considering 5G coherent, the most common use case is actually 5G mobile mid-haul and backhaul, and also front haul. So going forward, the type of speeds and capacities that we sort of envision to deliver with 5G as a service really requires connectivity at the level of 100G in the very near future. So 100G coherent is a very much essential requirement as we move forward with 5G. And network protection, again, where should I invest, or rather, what sort of protection that I should use in my network? Should I rely on optical protection, or should I rely on IP protection, or should I use both? Now, there's no point that you invest on multiple protection unless there's a very good use case. But most of the operators today try to use TILFA IP level of protection for traffic, or together sometimes with different optical protection. And onto the front haul side, we have this requirement of CPRI, which also can be transported over WDM. That means your front haul is going to be a WDM network, and or maybe try to use the Ethernet way of transporting, or radio over Ethernet. So we have both of these options, but you need to select, like you implement entire IP network here, and then use DWDM just in the front haul to transport CPRI, or you do really want to extend that same IP Ethernet capabilities towards the radio head side. And timing synchronization is another aspect, because you cannot really depend on satellite based timing options, because one thing, it is costly, and it is also complex. So you really need to use network based timing protocols and standards for that as well. Multicast is another aspect, although we often don't talk about multicast in 5G networks, but predominantly we see multicast, or rather most of our traffic types are now becoming unicast, which used to be multicast are now becoming unicast. So most of these options, although these options are available, the real implementation of these multicast options really depend on as to how much multicast traffic do you really want to support in your network. And network slicing is one of the key requirements in 5G, and also expected from the 5G transport, because one of the key requirements of 5G is actually to support multiple traffic types or multiple traffic streams, which requires different slicing, not just in the network, but in the computing environment, in the radio environment, in the data center environment, etc. So you have multiple options of supporting network slicing, like flexi and soft slicing, and that requires network programmability and sort of abstracting the network capabilities onto software, and then try to use concepts like software-defined networking. So software-defined networking requires that you have software-defined domain level software-defined controllers, and then the reason behind that, and also the reason behind why you need to have orchestrators, is because these networks do not scale gracefully or gradually. You cannot forecast, but you really don't know when it comes the demands. So you need to really have most of these things to be more adaptive and agile in terms of supporting the unexpected requirements coming from 5G and other future services, as networks increase in size and also capacity and also in capabilities, different functionalities, the manual intervention and people trying to manage and operate this network is really error prone and sort of inefficient. So we really need to have intelligence, control, and orchestration to handle that sort of networks. So your stack from hardware, a mix of hardware, software. We have the data plane, which is your transport infrastructure. Then you have your control plane, logically centralized. Then you have network orchestration, service orchestration, OSS, BSS, full stack. But you can have real, basically two splits. One is on what sort of capabilities that you expect to have on the OSS side, or really the operation support side, and what sort of capabilities that you really want to have on the SDN or the network, software-defined network side. And on the other side, we see most of the things are now, as I said, when once abstracted, they actually come to the level of software, leaving just the hardware, your transport gear in your data plane. So on one side, you're talking about software-defined networking and service orchestration. On the other side, you're talking about the split between hardware and software. Or maybe there could be areas where the service orchestration, network orchestration comes as one big software piece. Of course, within that, you have different components. So what sort of approach, especially in financially constrained economies or developing economies and in uncertain times, what sort of approach service providers can take in terms of investing to bring in these capabilities, which are essential for 5G services. Now, the best approach I would see is that have a bottom-up approach. Build your data plane, which is very much essential to have your footprint and capacity, and then implement the necessary control functionalities and start adding the other capabilities like your network orchestration, service orchestration, automation, AI, ML, as and when required, and make sure that the interfaces, whether they are software to software interfaces, hardware to software interfaces, or hardware to hardware interfaces, all the interfaces are open, and you support or rather follow cloud native and all these network concepts. So in summary, the transport network, I hope that the criticality of the transport network was evident to you because of the type of things that I mentioned, the type of considerations that you need to have in building a transport network. Although I touched them at very high level, you really need to go into detail in all these areas. So it's critical. And since 5G network is going to be end-to-end IP, very much like 4G, but also cloud native, the network too need to support cloud native requirements, something like elasticity. So network programmability is must to deliver 5G capabilities like network slicing. And then we really need a new design approach for 5G transport networks, and everything comes at a cost. So how you prioritize your investment on different capabilities and making the network an agile and flexible is very much essential. So that's it from me. Thank you very much. I hope, do we have any questions, Annie?
Yeah, we do, Anu. Thank you for that. Looking at that just makes me so glad I just write about this stuff rather than I actually have to do it.
Okay.
So first of all, one question for you is, how do you propose 5G sync, PTP, should be carried over transport, especially for indoor coverage where GNSS does not work, and in countries where GNSS is not allowed as only source?
Yeah, so if you have issues with getting the satellite for your timing and synchronization, then of course you have to rely on the network. There's no other solution. But taking it to the front hall level, going inside buildings, really one thing is that you are extending the network footprint. Let's say something that we used to stop at backhaul level. now goes to the mid hole and then goes to the front hole. And also maybe going inside means that we are actually lengthening the entire path for traffic, entire path for control signals, and also the entire path for your time synchronization as well. So it gives you a different set of challenges. For example, how do you really want to do it? Whether you want to use front haul with WDM type of connectivity, or really want to extend, as I said, your traditional Ethernet IP connectivity up to the front hole, and in this case, as the question, inside the building as well. So that requires you bringing in IP equipment inside the building as well. So on one side, as service providers implement their access networks on fixed side, like as we move from NG-PON to let's say WDM-PON, anyway, people, transport service providers will have some sort of presence in their PON network inside the buildings. So one way is, although these standards need to be verified and tested, one way is actually to use that network. So in that case, we will be using WDM-PON for that purpose. But then you have a disaggregation, or rather disintegration between your traditional IP Ethernet transport and WDM transport. So how do you integrate the clocking and synchronization is also a challenge. So taking timing and synchronization inside buildings has a different set of challenges. I think the industry not yet mature enough in terms of standardizing these things. I think we need to do a lot of collaborative work to bring in and sort of find these standards which suits these environments.
Thank you. And another question, we just have time to sneak in. What is the right transition level to define virtual transport network infrastructure to physical resources? Is it horizontally with path segmentations, or vertically from the top, encapsulating smaller data flows into larger aggregation layers?
I think in terms of aggregation, one we can do is, anyway, the traffic is the sort of architecture that we have in access aggregation and core networks is that from access we aggregate to the aggregation, and then aggregation to the core. So aggregation will anyway happen. But the question is, how are you going to do the aggregation? Are you do the aggregation at IP Ethernet level, or rather at optical level, use things like OTN, sub-lambda grooming, and things like that? So and on the other question that you have, the first question with regard to the virtualization, it really comes with the abstraction of network capabilities. How do you abstract your network capabilities, whether it is in the RAN or the transport or the core? How do you abstract your network capabilities onto software and use SDN concepts for software-defined networking and also network orchestration and automation? So I think we need to have both the layering of the horizontal view of abstraction and then virtualization, and also do the aggregation at the network level as we used to do. But you have the option of doing it at IP, optical, or a combination of both.
Anu, that was an absolutely terrific session. Thank you very much, and we hope to see you again soon.
Thanks, Annie.
Thank you very much.
Bye.